July of 2021. So I wanted to give you a little update on this mapping project that happened in June of 2021. What this mapping was to actually get a huge 100-foot tape measure and some orange marking paint for like surveying, and measure out all the plots in the cemetery, the 20 by 20 foot, and then they got like the 6-foot buffer zones between these plots. Some areas don't have the buffers, so you have to look at the map to get an idea of what I'm talking about. And so how accurate was this map? Well, it seemed to be pretty damn accurate, but it did reveal a few things. But first of all, you can actually now see an actual picture online with each record of what the actual plot looks like. So starting at the northeast corner, let me pause for the plane. Okay, so our reference point is northeast corner. The reason being is that it has the closest to a 90-degree angle as we can get. It's supposed to be 89 degrees. So go 20 by 20 and all this kind of crap, right? And what you're going to notice is that when you get toward the southern end of the cemetery, using the original plat map was surveyed by Eugene McClintock. I'm not so sure if he actually was physically on site when he drew this map, or if he just went on some just basic information on what they intended the cemetery to be laid out as. But once you get to the southern part, there's much smaller amounts of soil available than what it does indicate. What is available, I made a notation in the record, whether it's only 5 feet or 10 feet here, things like that. Now, what we've noticed now too is that the southeast portion of the cemetery is the oldest, and in the buffer zones, the 6-foot buffer zones, where there's like nobody's supposed to be buried there, it looks like they utilized a lot of that stuff throughout the cemetery, especially in the southwest area or southeast, for the headstones. So now that we have an actual picture of what the layout is, now I need to go back and update the records about what is actually found in those zones, what needs to be changed around, where the stone needs to be put properly, whatever, right? What else is there? Got a plane coming again. In some situations during the layout, knowing where those headstones were, we also know, like, there's little survey rod, little metal rods. Some are just pipes, some are just little teeny whatever pieces of metal, similar to rebar. And so, you know, I know it's accurate. It's got to be accurate if we're starting to find these things lining up with the measurements. What else is there? Planes are always distracting when I gotta pause. The far west portion of the cemetery doesn't just have your typical 6-foot gap. It will have an 11-foot gap. Now, the angle of the fence is not 90 degrees, so let's say the northwest portion is 11, southwest portion will be 12 feet. So there's that little bit of difference, but it's still pretty accurate. Those of you who have people buried there, especially the Frendel family, you had 3 different lots, except one was scratched off. Now you know. I guess you were asking, you know, where is it? Where are these plots? Now you can go back and look at it. There's orange survey flags in each corner. If you're viewing it on your phone, you might not see all these flags. If you got a regular computer, it's a lot easier. You can even zoom in. I didn't want to use big objects to like orange cones, because it can create an issue visually. But I might go back and update it to do some funny things and digital stuff. Now, that was like the first phase, measure all this stuff out. Second phase was take the pictures. Third phase is to actually do something called soil resistivity. So what the hell is that? That's where you're actually measuring the electrical resistance in the soil. And using that, you can find out a lot of different things. I'm not going to go into it right now, but different kinds of soil, or even clay or rock or roots, tree roots, all can affect that electrical resistivity. But you can also start to learn where the soil was disturbed. So if there's areas where there was not a lot of clay, like this particular measurement measures from surface to 3 feet. That's just the first phase of the resistivity measurement. So if they had stirred up the soil, they also stirred up a lot of clay and possibly rock or whatever, so that changed the resistance. And as you plot this out, you can start to see patterns. Some patterns are very interesting, especially toward the west end of the cemetery, and I'll probably get into that in a separate video, because this has to do with some people finding these weird magnetic anomalies. And there is a pattern and there is some science to it, and I found something. So we'll get into that. What else is there? I think that's kind of pretty much it. What I find fun is the front entrance today is not exactly in the position where they intended it to be with the new fence. Part of the Hagman lot actually extend. So when you walk in the entrance, you're actually walking over their part of their plot. What else is there? Yeah, that's pretty much it. So when you look at this, what I call the heat map, well, the sun's out. It's kind of a false color map. So there's the resistivity is going to be the green areas are more conductive and the red areas are less conductive. So let's take for example, the northwest portion of the cemetery. You're going to see a lot of red, it looks like a strip. And in that area is a lot of rock. There are a lot of roots. There is a lot of clay, so that would make a lot of sense. Some areas that have more conductivity, more green areas, you might be around some tree roots where it's helpful. That seems to be more conductive. I would say it's more about the soil, but there are some cases where the tree is causing resistance, like the piney trees, the nice green trees to the right when you walk in the entrance there. A lot of resistance, but there's also a lot of clay. Anyway, you just play around with this stuff, you get an idea, and you'll start to see the pattern. And so anyway, in the buffer zone, you'll see less resistance in some areas, and then just like in that perfect 20 by 20, super high resistance. Those will really pop out for you. You're gonna have a lot of fun, I think, if you understand some of this. Now remember, this is only a 3-foot depth. To do these, let's say 6-foot depth, which actually would start to reach where voids like caverns, or in this case caskets, the resistance is going to change, and that'll indicate more stuff. Darn planes. I think that's cicadas now. And before anybody gets upset, was everything disturbed doing this kind of testing? No, all this is it's a short piece of copper pipe. It's 4 of them. They only go in the ground 4 inches, and depending on how you space these poles depends on this electrical curve and how deep you're really sensing. Again, I'll go in deeper depending on, I'll spread those poles out and we'll get some deeper measurements. Other techniques, such as with this guy, this thing actually is meant for utility searching for like underground water pipes, gas pipes, that kind of stuff, and it has about a 10-foot depth reach. It varies. I'll get into this in the next video on how you can play around with this, and you can start actually detecting parts of, let's say, just metal objects on the coffins, and you can start to get outlines of where things are buried. So it'll go, below even where they buried, people, and it turned out really cool. It's just something fun to play with. Not exactly what you want to use, but it is useful. And depending on how you use this device too, helps us figure out some other mysteries. Again, another video. So anyway, have fun. Download the map. It's actually currently as a Google sheet, which is like an Excel sheet. So you can export that in a PDF or other image formats that you want. You can zoom in. There is another Google sheet that has all the measurements and notes and stuff like that. This is one of the most tedious, sweaty, painful projects I've ever undertaken. It is over 500 measurements, and with each phase, each depth, I got to do another 500 measurements. So I don't know when I'm going to get to this deeper depth stuff, but it's like non-invasive. It doesn't ruin anything, so don't worry about that kind of thing. anyway, yeah, we'll have some fun in the future videos on this other stuff. So, adios.